welcome back to the old shop and another edition of the old steam powered machine shop. This is number 12, and if you haven't seen the first video, I'd like to just briefly explain what we're about here. I'm trying to emulate a 1925 job shop, a small job shop under steam power, and what I wanted to do was see what it would be like to actually do it, to depend on steam entirely to run all your machines, and have to deal with feed water freezing up in the winter and trying to fire the shop in the summertime when it's really hot, and keep the belt system lined up and running properly, and you know, try to make money with it as a machine shop. So we've done pretty good with this so far. I got a few things I want to tell you about. The latest project that we're going to undertake is totally rebuilding or resurrecting a vertical steam engine. It's a 6x6 cylinder engine. It was found that had been disassembled for 30 years in the woods. And I'm going to show you the parts and pieces, the way they came into the shop, and then after I clean things up and inspected things a little bit, I'm going to show you a little bit about each part and what we're going to do to either remachine it and make it work again, or we're going to use what's left of it as a pattern to make the new parts. We already made a few parts. My trusty apprentice Tom has been in a couple times a week and has made a key for the small end of the connecting rod just from what was left of the old one, and also made a new pivot shouldered bolt for the valve rod. And these were some pretty simple parts. We thought we'd start with the simple stuff first before we get to reboring the cylinder and all that kind of stuff. So that's about all I have to tell you news-wise, and we'll get right to it. Thanks a lot. I wanted you to see this before I got too carried away with cleaning up the parts. But this is just the way it came out of the woods. It was sitting in the woods for probably 30, 40 years, disassembled. And these are some of the parts. This is the piston with the rings. The eccentric strap. Connecting rod with the two brasses. This is like Swiss cheese. Crosshead. Valve rod. A lot of these small parts were laying in a fiberglass tub that filled up with rainwater. So all you really have is just an idea of what the new part is going to have to look like. The crankshaft, supposedly, Albert said, was bent, sprung. So I've got to press the gear off, press the flywheel off, put it between centers and see how bad it is. The cylinder actually wasn't in too bad a shape. I'll bring the camera over here so you can see. See the ports. And other than being very rusty, I could see no cracks. It just happened to be laying in the woods with the cylinder, the open cylinder pointed down, so the rainwater didn't collect in it. Kind of an unusual designed frame, and because it didn't have a real base on it. I think it was unbolted from a component part, that it was built into something. I don't know what, and I don't know what this big gear on the end of the crankshaft could have been driving. Possibly a bigger gear on a water pump or some type of machinery. And I just got a feeling that this engine was actually built by the manufacturer of the machinery that it was driving, because I have never seen one. I mean, it's not revolutionary unusual, but I've just never seen one with the parts shaped like this. Now over here is a governor that was with it, and I don't think it was actually on it. I don't think it was part of the deal, but Albert threw it in. It's a 1-inch pipe size Pickering, and although it's pretty rusty, it's complete and can be rebuilt. Here's one of the main bearing caps. The Babbitt actually doesn't look too bad. I don't think it's been run that much. You can see the bearings here. And this is another governor valve body, which these are a little scarce because you can find governors that people have stolen off engines just by unbolting the top of the governor and taking them off. But you really got nothing unless you have this valve too, that with the spool and everything in it. So this could probably be adapted to some other governor top and a spool made for it. But that's what we got for a project. I've done a little research on this, and I'm pretty sure that this engine was part of a Hoist, a single cylinder Hoist setup. I'll show you a still picture of one similar to it that was made by O&S, but that's what this big gear is for on the end of the crank. There was maybe a 3 foot or 4 foot diameter gear that this meshed with on the drum, and this is the frame after I cleaned it up, ran through the shop blaster, and part of the frame, and the bottom part that has the main bearings is not made tall enough for the crank to clear, the center crank to clear the ground, so it has no base to it. So I'm sure it was bolted to a frame of a piece of equipment, so it would make sense. Okay, Tom's working on a part here. I think this is the valve eccentric rod pivot pin, right, Tom?
Yeah, I believe so.
So what's happening here?
Oh, trying to take that and make a new one from that. Essentially, it's going to go in there. And the other end threads into that.
I've had a chance to inspect some of these parts, and I'll show you a little bit about each one of them and what the plan is. This is the cylinder head, and it's steel shot blasted just to knock the rust off it, and shows no cracks or any problems there. This side I bead blasted because I wanted to get something to indicate on here, and I'm going to face off this surface and cut an equal amount off of here and off of here, so nothing changes as far as the combustion or the chamber volume. These reliefs are cast in here, and they go on the cylinder side where the steam ports are, so that it doesn't restrict the flow of the steam into the cylinder when the piston is up close to top dead center. I haven't seen that on any of the other engines that I've had apart. And we'll go through the parts one by one and show you a little bit about each one. The eccentric strap has got a babbited lining in here, which is pretty neat the way they did that. And like the main bearings, it shows no grooves or bad wear or anything in there, and I think we'll be able to clean this thing up and use it as it is. This is the governor. I don't know that this is the governor that was on the engine, but it is a Pickering governor, 1-inch size, and it's all complete. So I'm going to use it. These are hard to come by complete. This is very similar to the one on my shop engine, except this one has the ball ranger feature on it, and what this little knob here does, and it has a lock nut here. When you screw this in, it makes the engine run slower. When you screw it out, it makes it run faster within a certain range, as long as you're running it at the proper RPM for the governor based on what springs they supplied with it when they build it for a particular application. But it's very easy to adjust the speed on this one. You don't have to take the top off and shim it and play around with it like I did the shop engine. So I think it'll be a good governor. It's going to have to be completely disassembled and checked out and restored. The lower main frame of the engine has the two main bearings here, which are Babbitt bearings. These are the caps. Well, this is where you put the waste material in there and oil them. And the Babbitt looks, surprisingly, looks really nice. That's why I don't think this engine has been really run that much in its working life. There's no grooves in here or anything. The only problem is we've got to cut the crankshaft probably undersize, maybe 20-40 thousandths in order to clean up the rust on it, so it's going to make these bearings too small. Now we might be able to machine a little off the mating edges here, and then put it back together again and line bore the whole thing. Or we may have to re-babbit it. We'll figure that out after the crank gets done, and we'll see how much too small it's going to be for the bearings. The cylinder is 6x6, 6-inch diameter, 6-inch stroke, and I got it cleaned up, shot blasted, magnafluxed, and it looks pretty good. I mean, the wear surface in here is pitted and will have to be rebored. Might be able to hone it, but I think we'll probably rebore it, because there's down in the very bottom there's a few pretty deep pits, and we'll reface this off for the gasket to seal nice. This is a blind cylinder, which is a little bit unusual with steam engines. There is no bottom head. It's made with the cylinder. So when you bore this cylinder, you're boring down to the end, and it complicates things a little bit. And this is the packing gland that pushes the packing material, the graphite packing material, down against the rod, seals it. These are the ports, steam ports on the outside, and the exhaust port in the center. One big problem is I could not find the slide valve for this. It's lost. I'm going to go down to Albert's and look one more time. It may have got thrown in another box of parts or something, but I'm looking at the possibility of having to design and make a slide valve for this, and that's going to be quite an adventure. And if we do it, I'll show you how you figure it out using a Pilgrim diagram for getting the dimensions of the slide valve so that the timing of the ports works out right. This is the exhaust port here, and the intake port is here. So this would be a little different as far as piping up the governor. I'm not sure exactly how I'm going to do that, but we'll do that when we get to it. This is the crosshead assembly for it. It runs back and forth on these slides. Actually goes, being a vertical engine, it goes up and down rather than back and forth. And I bead blasted it to get the rust off it, and it looks pretty good. I don't think I'll have to really do that much to that. The main problem is the wrist pin here. It is really pitted, so we're going to make a new one of these, and we'll probably make it out of something a little better than wrought iron. Maybe we'll get some tool steel or something. It has to adjust this one, it has a bronze plate on the bottom that's a wedge. It's a tapered wedge. So there's a nut here. So to tighten it up in the groove, you force the wedge back with the nut, and it makes this wider. And it's a good design. This is the packing gland. It goes in the end of the cylinder with the packing material. Pushes the packing material into an angled chamber and forces it down tight against the piston rod. And there was nothing there. Tom put it in the lathe and just smoothed it up and faced a little off of here. This is the steam chest cover. I was hoping that I'd find something cast in it that was a clue to the make of the engine, but there is nothing. This is the connecting rod, which is pretty sad. 30 years laying in the woods. And I think what I'll do is grind some of this out and try welding it up, and we'll machine it flat, because the rod itself is pretty good, and it's a pretty complicated machining project. It has these are slots with an angled bottom that work against a tapered pin. Tom made these pins, a pin here the other day, based on this. We measured it up, we made the pin, and the idea there is it will goes in here, and the brasses on the wrist pin are forced together by this key, tapered key, and then you tighten the set screw to hold it there. And that's where the terminology keying up your bearings comes from. On a steam locomotive, if they get a little loose and make a noise, you'd loosen up whatever the setup was and hammer the keys in a little further and tighten them up. And then at the next stop, you'd feel them and see if they were running hot. That's how they could tell if their bearings were at the proper clearance. They would be just a certain temperature when you put your hands on them. And the same thing with the bottom end, only bigger. It's got a key. That'll have to be made. And the brasses, I think, are okay. There's no grooves in them. I mean, from wear. And This is the piston and rod. Got a busted ring. That could have happened while it was running as an engine, or it could have happened from rust. But as you can see, it's got two rings that are right next to each other with no land in between. My shop engine has a land in between. It's got three of them, one in the middle. This puts the two rings right next to each other, and the ends of them are sawed at an angle. And this is also a very convenient thing here. The end of the piston unbolts and comes off, so you can put the rings on there and then put the end back on the piston rather than have to stretch those cast iron rings way out to drop them over the piston. So I like that design. The rod is really pitted, and this will have to be made new. And this is the base. It fits like this, and the cylinder goes on top of it. And when I got it cleaned up, I found some cracks in it. There's one right there. I don't know if you can see it. It's cracked all the way around from the hole to the other side. And there's one started over here. So we'll have to repair that. We'll V them way out and weld them up with nickel rod. This little pivot pin, it fits in here. It's part of the eccentric setup. Was lying in a pail full of rainwater, and Tom was able to ascertain the dimensions of it and made up a new one the other day. So that's a part all finished. Well, Tom has got this pretty nicely blanked out here. This is the shoulder bolt for the valve rod pivot on the vertical engine, project engine. And according to his drawing, this part here will be threaded 3/4 10. And I really want to get this little south bend lathe set up so that we can do threading on it. It's it's a 1925 lathe. It's called a South Bend 9-inch Junior, which was kind of a stripped down version. It has no quick change gearing here. It just has a pile of gears, and it's not a complete set. I'm missing quite a few gears, and I haven't been able to find the ones I need like on eBay or something, because this older 9-inch lathe has heavier gearing on it than the later lathes. Like these gears are wider. It's a 16 pitch gear, but they're wider. So anyway, I looked through here and I found two gears that I can use to cut these threads, and I'll show you how I determined that. On any lathe, see, this doesn't have a any power feeds other than the lead screw. So it uses the lead screw for a power feed when you're just turning something. So it has to be geared down really slow. So they've got their thread gearing back here compounded with an extra gear set here to slow it way down. So when you're threading, you got to take that out, and I'll show you all about that. But basically, on any lathe, and I know this has been explained on a lot of other channels, but you guys are my viewers, so I'm explaining it here. But basically what you do is you find the pitch of the lead screw. So that's in 1 inch. This one has 1, 2, 3, 4, 5, 6, 7, 8 full threads, and then the next thread comes on the next number, and you don't count that. So this is an 8 pitch lead screw, and that's the constant that you have to work off of when you're threading something. So if you were going to cut an 8-pitch thread, you would run 1-to-1 with the spindle. In other words, this would turn the same speed as this, and you would always cut whatever pitch is on your, it would just duplicate this pitch. So you could cut an 8 thread with a 1-to-1 gearing. And I'll show you, I'll move the camera around to the back of the lathe so you can see the gear setup. Okay, this is the reverse tumbler. It's almost the same on all lathes, and all it is a couple of idler gears here, and to go forward you've got this gear between here and here, so this gear runs the same direction as that, and when you shift it down here, now it runs from here to here to here, so you got this extra gear in there, so it reverses the direction, which is pretty clever. When you got it in the middle, it's in neutral and it doesn't drive at all. So this gear is the same number of teeth as this gear. So basically the stud down here is the same as the lead screw. I mean the spindle. So all of this is just neglected when you're talking about thread gearing. You're just considering this shaft here to be the same as your spindle. Okay, so this has got this extra gear set in here that we're going to take out, and we're going to run from this directly to the lead screw. This is the lead screw gear, and in order to do that, you have a little formula. So any thread that you want to cut is going to be some ratio of the 8th thread on the lead screw versus the thread that you want. So here's the little chart. So if you got the lead screw number of threads per inch on top of your equation, and then the thread that you want on the bottom, that equals the number of teeth on the spindle, which is the same as this stud here, over the number of teeth on the lead screw here. So if you drop down here, we know our lead screw is 8, and we want a 10 thread, so that gives a fraction. And to make it easier, if you can reduce it to its lowest common denominator, so it can you can call it 8/10 or 4/5 is the same thing. And I looked through all my gears, and you have to find a pair of gears with this same ratio. And I had a 32 and a 40. So if you multiply this by 5, let's see, you get 32. And when you multiply the bottom of the fraction by the same number, you get 40. So 32 and 40 will work, and I have 32 and 40. And if you look at the little chart on the side here, it actually says number 10 is a 32 by 40. But there might have been other gear teeth in there, other gears with a combination that would have given you the same ratio. And that's all there is to threading. And so there's a few different gears that I need, and we're going to make them. So these old lathes are pretty cool. Everything is adjustable. You just loosen up stuff and everything moves around. So we're going to take this off. Hold it. Take that off.
and put the 40 on. And there's a little key in here. Don't want to lose that. But before we do that, we got to take this off. This is just going away. Okay. Let's see. It's make sure we got the right one. 40. I may have to take this spacer out. Turn it around. Sorry about that. Just leave that. And the 32 is going to go on here. Something to block the spindle with. Yeah, and this has got a, in order to get it in line, this little spacer comes off. And of course, it doesn't want to. The 40 on here. Put that on the outside, take up the space. Okay. Now the only problem is we got all this space in here. So if you put an idler gear in between here, it won't affect the rotation or the speed of this one. It's just an idler gear that goes along for the ride. So we'll put this back in here like that. It's got a bushing with a collar on the back side of it. And then this bracket is adjustable here, so we can bring that up. Set some gear lash in it. So that should give us the right combination. But we'll put a lathe tool in there and just make a very light cut just to verify it. Okay, this is a hand ground thread cutting tool, exactly 60 degrees. You can check it with your little thread gauge here, and you just make sure that the tool is lined up in the tool holder so that it fits right in there. I put a piece of white paper down here underneath it so you can look down through and see a little better. And then I want to just double check and make sure that I'm right on center, because that'll change. If you're not on center, it'll change the profile of the thread just a little bit. Okay, so we're ready to take a little trial cut. I'm running this lathe on my standby electric motor because the fireman already went home and we don't have any steam. Okay, it's just gonna touch it. Oh, by the way, I've got the compound set at 30 degrees. And let's check this to see. I don't know if you can see that or not, but that's a 10 thread, no problem. Now, another thing about this lathe is, and I'll move back here where you can see, it has no thread dial or any provision for a thread dial. This hole here is for a saddle lock, which has been missing for 50 years, and I'm gonna have Tom make one up for that. But the way we're gonna do this is, see now it's such a short thread here, we're gonna back the lathe up by hand on each pass, and when we get it down pretty close, I'll probably just run a die on it to size it to final size. All right. This is a momentous occasion. We have a guest in the shop who is a fellow YouTube creator, Mr. Mike Waller.
How'd you do?
Of Britannic Motorcycles. That's the name of his channel. And happened by this morning, and Tom is doing a little work on the pivot, the valve pivot for the steam engine, and this is what it's come down to. We're running the lathe by hand because to do this threading job, because we don't have a thread dial and I don't want to disengage it, and we're running it up against the shoulder, so we're just turning it by hand to cut the threads. I mean, it's a small thread and it's a short thread, so it ain't a real big deal. But this is about as primitive as thread cutting gets.
This is what it's got to go into. Do you wanna